Hello everyone, welcome to the first lecture on digital electronics. Today we will have some introduction about few terms related to digital electronics. First we should know what's analog signal. As you can see, this is a kind of analog signal. This is the time axis and suppose this is the amplitude axis. It can take any values from the amplitude axis or the time axis. For example, here the value might be 3 at time t1. Time, for example, just consider first second, and here it is second. Okay, we could guess the value at 1.5 second from the analog signal. But if we discretize this analog signal along the time t, we would have something like these. And so on. Now, for this time instant, we know the value of this signal, but between 1 second and 1.5 second, if we want to know the value between 1.5 second and 1 second, suppose we want to know the value of 1.2 second, we can't know because this part will not be present here. Only this value and this value will be there. Discretizing it in time axis makes discretized analog signal. But if we discretized it in amplitude as well, means both time and amplitude, we will get something like this, which is called digital signal. This digital signal, as you can see, has certain levels. These are not connected. So between T1 and T2, if we want to know the value of the signal, we can't, because we know the value of T1, T2, T3, but not between these. And it has certain levels like 1, 2, 3, 4, 5. But apart from this level, if we have something 2.5 or 2.2, suppose we have 2.2 here, it will be just considered as 2, not 2.2, because we don't have that level. Now, a question would be arising, why digital signal? First is for the minimization of noise. What is noise? Suppose, for example, you are sending some signal to your receiver via transmitter. This is receiver, this is transmitter, this is this channel, and additional signal noise is being added here. You sent 2.5 volt, but the receiver got about 2.6 volt. This 0.1 volt is the noise. So suppose in the case of analog signal, if you are sending a signal, for example, like this, which has 2.5 volt, and the receiver is getting it 2.6 volt, this distorts the signal. This is the noise. Now, in the case of a digital signal, if you try to send the signal 2.5 volt, it comes out to 2.6 volt. The level 2.5 remains, because if there is a level, for example, here 2.5 is the level. Okay, in a digital signal, for example, 2.5 is the desired level and there is 0 level. Anything close to 2.5, for example 2.6, would be limited to 2.5 only, not 2.6, because we have only two levels, 0 and 2.5. So 2.6 would be considered as 2.5 in digital system. Now, analog signal can fluctuate so much. You can see it could go for example 10 to 0 to 10 volts in this case. But in digital signal we have limited amount of levels in amplitude. For example, here we have 5 levels only. So 5 levels, 6 levels, these are some limited amounts. We need less bandwidth and we are obtaining here. For long distance transmissions, it is better, it is efficient, it is immune to noise, that's why. Also it has some encryption properties which are beneficial for transmitting sensitive data. We could protect the data in fact, but in analog signal it is not usually possible. Now, how does the digital system work? Here is the analog some input and you are giving it to the digital system and the digital system is giving you the analog output, but actually it is not like that. Digital system takes digital input and gives digital output. So we need something to convert this analog signal to the digital signal and digital signal to the analog. So we have ADC and DAC. What is ADC? Analog to digital converter. And what is DAC? Digital to analog converter. Analog input is fed to ADC, which converts it into series of digital 1, 0, etc. And this is a bus. There might be a single wire or there might be multiple bits. And the digital system also gets it back, and DAC fits it back to the analog output.